Aquí te pico.
Espérate, ¿seguro que no accesas a nada a mis notas?
Sí, seguro.
Ok.
We are ready, Edna. You can begin, please.
Well, thank you, Hector, for inviting Samlex to offer this webinar, and thank you everybody for attending. My name is Edna. I've been the applications specialist for Samlex for the last 2.5 years, and the goal for this presentation is to go through some of the cases we have encountered in the field, their troubleshooting process, and finally, to explain what could have been a better approach on the installation perspective. We're confident that this knowledge or this presentation can be helpful to you no matter which position in the learning curve you are at. This information will be useful to you whether you are an end user or an experienced installer. So thank you for joining. A little bit of housekeeping before we go into topic. This presentation is only a guideline based on inquiries that we have received from our customers. Please follow up all rules and regulations specified in your location. And if you have any questions, of course, don't hesitate to send them over through EPCOM, and we will team up to address them. What we will see in this presentation, it's going to be mainly power supplies and some installations of inverters. In both cases, we're going to see the most common inquiries and how we troubleshooted them, and the installation mistakes that we had to address in order to fix the power system. Power supplies, most common inquiries. We do get this question pretty often. It's what is the difference between my SEC 1235M and the SEC 1235P-M. So we created a little table here. Aside from the meter, which in the P-M, the backlight can be lit, the main difference is in the AC input of the unit. The 1235M, they both work in a 120 volts AC and 240 volts AC environment, but the 1235M, you need to open the unit and make a little adjustment inside the unit and then close it up, and then you can use it in a 240 environment. Whereas the new version, which is the 1235P-M, it also auto senses the presence of the 120 or the 240 without you needing to open the unit or do anything to it, which is a very nice feature. Side of that, the display meter, the unit is a power factor corrected. We put some brains into it. That's handy. Makes the unit more efficient, and it does meet the minimum energy performance standard, which was brought by the US, also known as MEPS. The efficiency level, it's 6. They both are UL listed, but the 1235P-M, it's CE certified for its global use. So just a little bit highlight over here. Again, the 1235P-M can be used in 100 to 240 volts AC, and it will auto sense the input. You don't need to change anything in the unit. The display meter lights up. It does include power factor corrected. It does meet MEPS. Its efficiency level, it's level 6, and it's CE certified for global use. All right, so how can I troubleshoot my power supply? We did put together two cases, I think. The case one, the first case would be when turning on the power supply, the switch it doesn't light up and the load obviously does not turn on. First step on this would be to verify there is AC from the grid. You're getting a stable 120 volts in America's case, and you can use a multimeter, the good old test of connecting a desk lamp on that outlet. In this case, we use the multimeter, make sure that it's set for the volts AC setting, and try it out. In this case, we're getting 118.2. So that wouldn't be a problem. Then having the AC side of the unit blown, like the AC fuse of the unit is blown. How do I know this? You open the unit, the AC side, the AC fuse, you should be able to locate it. In this case, it's at the bottom or in one of the sides. You can see that on the right, there is the output of the unit, the DC output. So change the AC fuse. To what? The values are in the spec sheet. You can go to the samlexamerica.com website and there is a look for the exact model you are requested that you are interested in. Then go to that product. On the right side, there would be a download section. Look for the spec sheet and it will tell you which AC side fuse you need to get. Then the last case would be that the unit has shut down due to over temperature. Now, we actually do get this case very often. The first sign that the unit is heating up and it's going into an over temperature state is that the fans of the unit are coming on very often or that are very loud and they are trying to cool down the unit. Now, this often happens because the vents of the unit are blocked. Now, make sure that all the vents are, like the unit there is open airflow going through and that the environment where the power supply is in, it's free of dust because all the vents will suck all that dust in and will prevent the unit to cool down and it's not good for any power supply to have dust inside. Any power device or energy device. Or it can be that the load that you are trying to connect to the power supply, it's drawing way too many amps. Maybe the load you're trying to connect, it's not the correct load for the power supply. This is also this is often a case that we get to. And to make sure that your load do meet the specs on the power supply, check the label, check the electrical label on your load, and it will tell you the amount of amps it needs and to power up and to function, and see if it is compatible with the power supply. Again, you can see that in the spec sheet. You can go to our samlexamerica.com website, go to your product, the download section, and get the spec sheet. Or if you want to inquire, you can ask EPCOM and EPCOM will reach out to us. Second case of troubleshooting, when I turn on the power supply, the switch lights up. The DC output voltage, it's in a hiccup mode. This means that it's not stable. It kind of jumps up and down. First possible cause is that the output side it's overloaded. To get the unit out of this mode, we need to reset the unit, turn the unit off, wait some seconds, and I usually wait longer than what's needed, and then turn the unit back on and measure the output. You should read a steady 13.8 volts DC. 13.8, 13.9, it's okay. If this fixed the problem, do verify that the electrical specs of your load do meet the power supply, because it might not be the adequate load. We have had some cases of people trying to connect like a fridge to the power supply. We haven't tested that scenario, but we have encountered a couple of those. Okay, so again, double check the electrical specs of your load and make sure it does meet the specs, the electrical specs of the power supply you're trying to use. Second part, it would be that you might have a short circuit on the load side. Now, maybe a cable is not, the integrity of the cable, it's not good. So that might be it. So to get out of this or to fix this problem, you need to switch off the load first. And then disconnect it, check the integrity of all the cables, and make sure you're using the provided PTNB terminals. The power supply do come with a bag of accessories. The PTNB terminals are lugs to put in the cables that you are gonna be using to connect the power supply. Do use those. I highly encourage not go with the bare stranded wire into the unit. We have seen that often as well, and it just creates problems, which we are going to see in the future, actually, in this presentation. Now, another inquiry we get with power supplies is how to adjust the volts DC output in the SEC 1235 P-M. So the output of this unit, it can range from 12.5 up to 15 volts DC, stable. So you need to open the unit. Now with a Phillips 1 screwdriver, turn the VR1 component that you can see it in the yellow circle, and that's the potentiometer, and switch left or right according to your needs. Okay, VR1, it's on the image on the right, we can see just a zoom in image, and yeah, just measure the output with a multimeter until you get to the point where you want to be. Okay, so this is one of the cases of the power supplies that we have seen not using the proper cord and terminals or the PTNB provided. This also happens if you are not using the right cable, if you're not using the right gauge, or if the cables are too long. So again, we are dealing with power, and let's have some respect to it. We cannot just plug the cable right in, and this makes that the cables do heat up to the point of melting. And this can caught fire. This can get in fire. That's why we are trying to focus on the installation of our devices, because we have seen cases and it can be not good. This is not to panic anybody. It's just spreading some awareness of the importance of a good installation. It's good for you, It's safe, it is good for the device, because if you do take care of the good installation, the device is gonna be good to you for longer period of time. Okay. All right, so switching to the installation of inverters. Most common inquiries. Why does my inverter have a constant high pitch noise? Case one, and the most popular one, it is that the battery is not providing, so you have a low voltage of your battery. How can you measure this? Well, you switch on the inverter with no load. So take all the loads out so you can isolate the system. The power on LED is on, and the status LED on the GFCI is green in case your inverter has a GFCI. So it is a low DC input voltage alarm, and to troubleshoot that with a multimeter, check the DC voltage of the battery terminals and make sure that the voltage is higher than the low DC input voltage alarm threshold. Again, you can find that in samlexamerica.com on the look for your exact model in the search bar, go to downloads and get the spec sheet of that product. The setting you're looking for it's the low DC input voltage alarm. Let's say that the low DC input voltage alarm of my inverter, it's 12 volts or 11 volts. So if your battery is below that, it will have a high pitch noise and it will not turn off until it senses the battery going up to the low DC input voltage alarm threshold. Okay, so that it has recovered. Second would be making sure that you're using the right cord and terminals. Again, that you don't, maybe your battery, if your battery is correct, like it has good life in it, it is 100% charged, then maybe you're not using the right cord and terminals, or the cables you're using are not the right ones. So do verify that. Pull the DC cables to make sure they are tight. These cables shouldn't move a single bit. So give them a little wiggle and make sure that everything is tight on the battery terminals and at the unit itself. Okay. If there is some movement, then the touch or the contact between the terminals and the inverter, it's not full. And if it is not fully connected, there is the voltage and the energy needed, it's gonna be higher and it's not reliable. So full contact and those connections need to be tight. If in the battery they are tight, but the battery terminals are rusted, then you need to clean them, because that also provides some isolation of it prevents the power to flow through as it should be. Now, with a multimeter, you can measure now the voltage drop. This will let you know if the cables are the right size or not. So with the multimeter, we measure the drop voltage from the battery terminals to the input of our unit. The difference should not be higher than 0.5 volts. Okay. So for example, in this scenario, we do have a voltage DC at the battery of 12.53, and at the inverter, it's 12.50. If you actually call us, which is in this case is correct, okay? But if you actually call us with this case, or we're gonna need these numbers, the voltage at the battery terminals and the voltage. Another part, it would be that the batteries, it would be a sign that the batteries are getting close to the end of their life. Okay, so you can make a no-load test. You can take it to wherever you purchase the battery in case you don't have the device to measure that. And they will let you know exactly how much life is left in your battery. These are some installation mistakes that we have seen in the first picture. So it's a 2000 watt inverter, and the cables are definitely thinner than what they should do, than what they should be. And these are the connections of the battery. So on the picture on the right, you can see the cables that he or she need to use are the ones on the right. And the black and red cable on the left side are what he was using. So definitely something to consider. So installation mistakes on inverters, not using the right PT-NB terminals, and the stranded wire should go like going straight to the terminal block in the case of the EVOs. This is an example of an EVO. And yes, the stranded wire that's going straight there, that is not good. The EVO in this case to come with the accessory kits. All of our units, most of them have the accessory kits. All of them, all of the applicable accessory kits come with the unit. So do use them. They are there for a reason and it's safer for you. This is another common one. Not having fully contact on the terminals. This person is using the right wire gauge. It's using the right terminals, but it is not fully flushed to the terminal, to the input terminal of the unit. It's almost, and you might think that it is, but it is not. A little bit of angle makes a difference. There should be no gap. And this is an example of the batteries presenting corrosion or being dirty, which will also play a part in your power. In this case, the inverter was faulted, what's faulting as a low voltage alarm, but the real reason for that was that the battery terminals were dirty, were corroded, and until that got fixed, the unit worked fine. And that is it from my